This is my 2003 ThinkPad X31, and in the upcoming days I'm going to try and develop a game for it, like it's 2003.
Yes, here we go again, give you all nothing lesser. Back on the mic is the antidepressant.
I'm not actually going to use any game engines for this sweet little machine I have over here, but instead I'm going to develop it from scratch with C++, OpenGL and SDL, if I can figure out which versions this thing can run. So this video wouldn't live up to the 2003 vibes if it were recorded in the shittiest possible format I can possibly find. Alright, let's switch up the camera quality real quick. So 3, 2, 1. And here we are in the 2000s. Look! This thing... Shit. This thing doesn't look nearly as outdated. You know what? I'm actually kind of liking this vibe. Very Windows XP-like.
Oh my god.
So, my first clear objective was getting SDL to work, and SDL is basically just a library for window management and input handling. I downloaded SDL 1.2.15, I tried to link it, I linked it. Making my way through some of the documentation, I successfully wrote my first piece of software, which was Robloxman Cursor.exe. Very impressive stuff. I later upgraded it to a bouncing ball, which makes use of simple gravity and collision. And at this point I was feeling rather confident in my dry C# my C# my C++ skills. So I decided to dive into the OpenGL example included into the SDL documentation. Body is OpenGL 1.3, which, to put that into perspective, is 15 major releases behind. It's a little vintage. So the rough idea with 3D models is that they are made up of vertices and triangles and some other stuff we'll touch upon later. And the GPU, your graphics card, is designed exactly for quick triangles rendering. And to render anything to the screen, we need to basically tell the GPU where it can find the 3D model data. And this is where OpenGL comes into support. Basically, OpenGL acts like a sort of layer between me, the programmer, or you, the user, and your computer graphics card. So basically with OpenGL we can talk to the GPU. And this version of OpenGL doesn't support vertex buffer objects, which are high-speed buffers, streams of data, that are uploaded directly into video memory. 1.3 doesn't support these VBOs, so we're left off with reading 3D models from RAM. And you see, to put 3D data into RAM, you need to import it somehow. And just thinking about writing a 3D model importer in C++ give me a stroke. So I got Python 2.3 installed and started working on a simple importer. The importer is actually very simple. It reads off every OBJ file in the current directory and produces header files, and I also named it after my toothpaste. Then in C++ I can simply point to these arrays, header files, and get my model rendered, hopefully. But yeah, it didn't work. I fixed it and it still didn't work. And at last I wrote on the graphics programming Discord server, and some kind gentleman linked me to the 1.3 docs, which I still have no idea on how it works. So there, the cube renders, but the cube is fucking white. The cube is not realistic enough. So, back to the drawing board. Lighting. Well, actually, vertex lighting. You see, per pixel lighting is very expensive, so instead we can just fake lighting with lighting the vertices of a model and let the fragment shader blend them. Fake shading, basically. And bada bing, bada boom, we need to just enable a couple of features, light point, and just kidding, it wasn't that easy. We also need to buy novels. So hear me out for a second, please. Hear me out first. Getting textures to work was not as easy as normals because of my poor design choices while making the OBJ importer. So I have just realized that using a multi-stream approach is actually fucking dumb for models, because when using textures and UVs, when faces share the same UVs, everything breaks. So I have to basically rewrite most of my code to use a single stream approach and most of the importer. Okay, so now look at this. We have a single vertex array. The importer was written a single phase buffer. We have a skybox, and the model renders correctly, so yeah. Finding a math library that was made in the early 2000s and that was tailored at game development was also quite a head scratcher, but in the end I settled with irrlicht math, which is a math library for the irrlicht engine, and I chose it because it's a single header and did everything I needed. So I got it installed, linked, working, and whatever else, and worked on implementing a free view camera to make use of its quaternion class and just take familiarity with the library. Okay, so after finally getting all of that to work, it's finally time to decide what game to make. You already know, it's an FPS game. I can't believe it, I got it working. 20 AM. But yeah, after a bit of coding, we have collisions working. This was ported from my C# demo. Oh, Jesus. Next up was actually running an FPS controller to, you know, have an actual FPS game. And I've written so many over the years that I whipped out another in less than an hour basically, even though I had to write it in C++, which was like torture. And it's your usual Quake-inspired character controller with the wish there, the wish speed, and all of that cool jazz we know and love. But other than that, the camera is snapped to the player's origin, and some magic vector projection basically rotates the wish there according to the camera orientation. Okay, so copy the textures from the Wizard of Oz for the DS because I love them so fucking much. What's that noise? I can't hear. Repaint some of them and dither. Create some planes in Blender and smash them together. Enable alpha blending in OpenGL and finally export. Unfortunately, there are no gameplay mechanics in place, so yeah, it's just a cube walking simulator, but I figured it was still cute enough to show off, basically. I was going to add some rifles, some shooting at the wildlife, you know, some casual gaming stuff, but yeah, I can pull any willpower left in me to actually sit down and make it. So there it is. I'm sorry if I lied to you. The video should have probably been named something like I made a game engine like it's 2003, but yeah, whatever. I mean, it is what it is. I won't talk about the technical details, just know that I skipped over a lot of stuff just to make the video entertaining, because I could have talked a lot more of the boring stuff, basically. But if you want to really look at my code, for whatever reason, you can actually find it on GitHub. Most likely, I will have uploaded it at some point, I don't know. But yeah, so that's about it. I hope you enjoyed this video. I hope it's my first actually well-made video, and yeah, take care.